Hello and welcome in. My name is Mark, aka the Markster, and this is video number 52 in the FreeCAD series. Today we're going to take a look at the various draft array types. We've already covered, I think, 3 of these, and we'll cover the others in this video, and we'll cover all these in this video. Let me show you which version of FreeCAD we're using. So this is 0.19, revision 20036. This is one of the development versions. This was compiled, I guess, about 4 days ago. Alright, so we've already looked at a couple of those arrays. The Ortho Array, the Polar Array, and the point array. But we'll cover them again. Let's create an object that we can use as something to make an array out of. So here in the draft workbench we have some drawing elements similar to what you have in Sketcher, except the difference being you don't have constraints in the draft. So I don't tend to use these at all, but some people do. Not for this type of work, but for drafting. You can enable a grid, which I have disabled in my settings, but you can enable a grid here and then snap to the grid as you're drawing, as you are drafting. But I'm just going to put, with the multi-line tool, sort of an arrow looking thing. And I'm going to press the O key to close this object. And then I'll go to part and I'll extrude this wire. That's just to get something to serve as the base of our arrays. So let's do the first type, which is the ortho or rectangular array. So by default, each interval is 100 millimeters apart. You have 2 on the X, 2 on the Y, 1 on the Z. You can use, you can fuse the objects together, or you can use links. What does that mean? Well, if you select fuse here, the objects will be fused together if they touch each other. This will help you resolve problems, self-intersection problems. If they're fused, you won't get those. Let me show you an example of that. Let's make 3x and 3y and 1z. Select OK. That's quite a large array. Let's change these intervals. Okay. Oh, I have the wire instead of the extrude. Select the extrude and do this again. And I'm going to make them just 3 millimeters apart. And 3 and 3. So they're 100 millimeters apart in the Y interval, but only 3 apart in the X interval. And if we go over to part now And if we do a check geometry, we get all these self-intersections. So the way to correct that error, let me clear this out, is set fuse to true. So now they're fused and you won't get that error. So if you run into that error with your arrays, or if you try to do some Boolean operation and it fails, check to make sure that if your objects intersect each other, that you have fuse set to true as this property. If we wanted more in the Z direction, so that's that type. We've already covered that. Go back and watch the first pegboard video. We use this type of array. I also use this in the honeycomb maker macro. Alright, let's see the next type. Go back to draft. So here we have the polar array. The default is 180 degrees, 4 elements. And we have the same fuse and use links option. The use links option, let's talk about that. If you elect to use links, you get links instead of simple copies. That's said to be more efficient. I have not tried that, I have not tested it. The link is just a reference to the original object rather than another copy of that object. Mostly, my understanding is links would be used where you want to link to an object in another document rather than copying that object to your document. So you could use that in an assembly, so you could have multiple documents with multiple objects that you want to create, that you want to put into an assembly. Then that's what this links tool was created for. That was the motivation, I believe. Alright, so here's our polar array, 180 degrees with 4 objects. And there's 7. So we have a bunch of properties in here. Some are for the ortho type, some are for the polar type, some are for the circular type. Well, some of these are irrelevant. So for polar arrays, the only thing we would use would be the angle. So let's say we wanted 270 degrees. Or we would use the axis, which would be the axis about which to create the array. Of course the base, the center of the array, whether to fuse or not, and the number of polar. Those are the only ones relevant to the polar array. Alright, so that's the polar array. Very useful array type. And the next one we'll look at is circular array. This is a very new object. First time I came across it, I didn't know what it was. So here the default radial distance, in other words radius, is 2000, which is quite large. I'm going to make it 20. And the tangential distance 10. Number of layers 3. Symmetry 1. Center is at XYZ equals 0. We'll come back and talk about what these mean. So here's our circular array. The first object, which I didn't put on the origin, let me show you where the origin is at. That's why it's out here. It just shows up where I drew it at. Turn this back off. So this is basically two polar arrays, two 360-degree polar arrays, and that's where number of circles comes in. The initial object is considered circle 1, then 2, 3, and 4. So that's why you have 4 instead of 3. Now in the polar arrays, we select how many objects by this property. But with this circular array, this is calculated for us based upon these three properties here, based upon the radial distance between circles, symmetry factor, and tangential distance. So let's talk about radial distance first. Well, this is just the radius. Let's set that to 50. That's easy enough. But notice we have a lot more elements now because we have a larger radius. So if I set this back to, say, 20, we get much fewer. We'll talk about symmetry in a moment. Tangential distance is the distance between these objects. So let's set this at 5 and you'll see the difference. And go to 25. So our number of elements is based upon the radius and how far apart these objects should be. And this radial distance is whatever the center point of this object is to the center of the next object. So if this were a circle, instead of this shape I drew, then it would be the center of that circle to the center of the next. That's the tangential distance. But if you think about it, you have to satisfy one sort of constraint that you have with this, in that you need to have a number of elements that's an integer. So if we have, let's reduce this to 2 circles just to simplify things. So if we have 5 elements here, that's the number that we can have. We can't have 5.1 or 5.2 or 5.0769. We have to have an integer. And it's not always going to match up to this tangential distance at this radius. So it just gets it as close as it can. Let's set it to 25.1 or 26 even. With 26 it changed. 24, 20, oops. Pressing 2 changes our view. 2 goes to the front view. 2 goes to the top. That's what these numbers are for. And I pressed it accidentally. So this will be 26. 26 changes it, 25 changes it, 24 does not, 23 does not, 22 does not, 21 does not. So all these cannot be true, right? So whatever is closest that it can give you, it'll give you that number of elements. So this is 6. And that's 7. Now let's talk about symmetry. What's meant by that? Well, we can rotate this object such that this one will be exactly where this one is at, right? If we rotate it by some amount. And our goal might be, we want to get that position lined up by rotating by only, say, 1/6 of a rotation. So we can set this number to 6, and that means with only 1/6 of a turn, which is 60 degrees, we can get these objects where this one is positioned here, or here, exactly. Just so it looks like this unrotated. That could be useful perhaps in doing some sort of animation, where instead of going all the way 360 degrees, you just want to go 60 and then back to 0 and loop like that, and it'll look like you're going all the way around. It could be other uses for that too, I'm not sure what, but this symmetry is going to override this tangential distance. So in order of importance, I guess you could say, radius is, it's always going to be this radial distance. Tangential distance will be as close as it can get and still have an integer number of elements. And symmetry is going to override this tangential. So what I'm going to do is create a clone. So we'll have something to look at while we rotate 60 degrees. Should put us back exactly on point, because that is 1/6 of a turn, 360 over 6. If we were okay that it might take a full turn, we can set symmetry to 1. If we weren't that picky about it. If we wanted to ensure it would take at most a half a turn, we set it to 2. And now let's turn this one 180 degrees, and back in alignment. So that's what the symmetry does. Let's move on to the next. And that is the path array. Now it's got path and path length listed separately, but it's really, so we really have 5 types, or 10 types if you want to think of link arrays as different types. So the path array requires a path. We can have any path selected, similar to the sweep tools. You sweep along a path, you array along a path. So let's just make a little path here. And finish as A. Alright. And now we select our extrude object first as the base, then the wire, which is our path, and we select the path array. And we have 4, 11, 20. So this object is drawn away from the origin, and that's why it's not right on these points. So the center of this object is actually like right here, because I didn't draw it on the origin. So this is the path array. Now we have an option here called align. If we leave it false, all the objects are aligned in the same orientation as the original object. But if we set align to true, it will attempt to align these objects to the path. And this is really not a good example of this at all. Let me delete this. And let's add, well, let me close this. View, let's add a point. We'll put it at 0. We'll use a point object. Alright, and now let's select the point in the wire, and let's see if we can create a path array of those points. So they're on the wire. I think you can see a little bit better how they line up on the edge, but they're not going to show alignment well. So let's try something else for that. Let me delete this, and let's try the circle. How about that? And put the radius at 10. For some reason it did something wrong. Enter. Okay, there we are. And I'm not going to pad that, I'm just going to use that. So we'll select the circle, then the wire. Oops. Circle, then the wire. Don't double click. Path array. And let's set this now to a higher number. So our circles now, let's try to align them true. You see how it aligned them to that object. And we can rotate that original object if we want a different alignment. Let's rotate around the x-axis. Try 45. So you see how to align them. You might need to go ahead and extrude that to get a better look at it. And let's set the base from circle to extrude 01. Still leaves me in wireframe mode for some reason. Doesn't like changing on the fly. Alright, extrude as a base. Path array. Alright. 25. Align true. So it orients them, aligns them to the path instead of to the how the original object was oriented. Shows up better with something with a point on it. How many of these am I going to do? Just sketch a little something here. Alright, now I going to bother constraining. Alright, let's use that as the base wire as the path. And oops, wrong workbench. Path array. Okay, now let's set alignment to true. And let's set the original object rotation. Let's go minus 90. It's kind of hard to see, but they orient along that path. So path subs, well, xlate, let's look at xlate. So this just translates in x, y, or z direction. So for example, if I move above in the z direction, it puts them above there. That's just a way of sort of tweaking where you want it at. So now path subs, what does that mean? Well, we don't have to select the entire path. Let me delete that one. Select our extrude as our base. And instead of selecting the entire path, I'm going to select just a few of these, holding down Control key. So let's say that's all I wanted to use for my path. Alright, and then we'll look at here, we'll see the path sub-objects that were selected, edge 1, edge 2, edge 3, etc. And the next one is point array. I'm going to skip this one because it's basically the same thing, except you'd be using links instead of the original object. So the point array, we used that one already in the die videos. There was one I made very early in the series about a die, and we used the point arrays as points in a sketch to line up where some spheres were going to go on the faces of that die in order to cut the little dimples, the little pips out. So we don't have to use a sketch with points. It's a really convenient way to do it. But you could also use these points here in the inside of a compound. So let's look at doing that. Let me add also a circle because I want to show you this feature here. And cancel. Let's set my view from the top. Alright, now add a circle. We'll enter the points because it'll be on the origin. We'll make it a radius of 10, press enter. And so now, if I wanted to add a point in the center of that circle, what I could do is make sure this is enabled right here. And then select this as a snapping option. And then when I select my point, when I come here close to it, notice how the little icon shows up, and I can get a point in the center of the circle. I also have, let me disable that one. I also have this option, which is the end of the edge. So the one I'm closest to. I don't have to be particularly close. I got my point on the O. Let's select this point here. So I have my point on the edge. You see it. If I want to put one on the edge of here, I need to go into point mode. So there's a point there. And if I wanted one in the middle of this edge, deselect that, select center, click on the point creation, and I can put one in the center. So now I go to part and I make why is it still in that mode? Let's turn that off. There's a little bug there. Alright, I'm in part now. I'm still with the wrong cursor. This is a little bit buggy, folks. Let's see if it'll let me select these objects. Yeah. Turn you off. Part. Well, I'll select them over here then. How about that? How you like that? And then make a compound. Alright. Go back to draft and select our whatever we want as the base. I'm going to select this extrude here and the compound, and then choose point array. So we have one at each point. And there's no option to change how many, because that's defined by how many points you had in that compound. Well, those are your draft array types. That's going to do it for this video. We can make the point array using compounds of draft points, or I'm sure you confuse these two with the fusion, or points in a sketch. Points in a sketch give you more control. You could probably create sub-objects, a copy of sub-objects. Import, I haven't tried this yet. Port, create a copy, shape element copy. So we have a bunch of these, and let's compound these. I don't know if that's going to work or not. We'll try it. Go back to draft. I'll delete that one. I'll select the circle this time and this compound and point array. Didn't work. No points found. So sub objects are not going to do it. Alright, well, that was just an experiment. I thought it might work. That's going to be it for this video. As always, I thank you for watching. And as always, have a great day.